Hello everyone and welcome to the fifth video. Today we'll be doing a work problem. Let's get started. The question is, we have a 30-pound box A which is released from rest. So I'll keep highlighting 30-pound box A released from rest and slides down along the smooth ramp onto the surface of a cart. If the cart is prevented from moving, determine the distance S from the end of the cart to where the box stops. Coefficient of kinetic friction between the cart and the box is 0.6. So this problem you could do with kinetics, right? But it would be longer than doing it with energy, because with kinetics you would have to first, do your free body diagram, get the acceleration at B, and then do kinematics to get where it stops. That would be 2 steps. It's not difficult, but it's 2 steps compared to doing it with energy, which you'll see is just going to be just 1 step. So what's our formula for work and energy? It's just T1 is plus sum of the forces from 1 to 2 is equal to T2. So we're going to look at the system from the start to the finish. We know that the kinetic energy T1 is going to be 0 because it starts from rest. T2 is also going to be 0 because it stops at the end. We know that there's going to be work due to gravity. The work due to gravity is going to be mgh. So we have to keep in mind that positive work is when the force is in direction of motion, right? And negative work is when the force is in the opposite direction of motion. All right, so here mg is going to be pointing down and our direction of motion is also down, so this will give us a positive work. So mgh, we know it's a 30-pound. We don't have to account for that, and the height is just 4 feet. And then we also have the force of friction, right? The force of friction here, the direction is going to be here, but then the friction force will be preventing the motion here. So our work due to friction is going to be mu k n d, and we know mu k is 0.6. Oh, I should have a negative. N is 30, right? Because if you were just to do a little free body diagram, mg, and this would be n when it's on the ramp, right? And d is what we're looking for. So if we plug that in, we have 0 plus 30 times 4 minus 0.6 times 30 times d is equal to 0. Solving for d, we get d is equal to 6.667 feet, and then they want the distance s. S is just 10 minus d, which is going to be 3.33 feet. And that's our answer.